project would be given this week. The project you are going to submit. Okay? The project, the final project, that outline would be given this week. Share in the Piazza. We'll share in the. So let's start today's class. So different type of parsers. Let's start from here. Classification of parser. Okay, so what is the classification of parser? Can you tell me? We have already given some hints last class.
Top down and bottom up.
Yes, so basically any parser can be initially classified to two broad categories. Two broad categories. So initially, one is called top-down parser. From here on, we'll call it TDP. And another one is our bottom-up parser. Or BU2. Here on, we will call it BU2. Top-down parser can be classified to two broad categories again. One is called TDP without backtracking. Another one is called TDP with backtracking. What is the example of TDP with backtracking? What is the example of TDP with backtracking? Brute force parser. And TDP without backtracking can be classified to two categories. One is called recursive descent parser. And another one is called non-recursive descent parser. And like this example of non-recursive descent parser is LL1. Okay. Now let's go to bottom-up parser. Bottom-up parser can be classified to two broad categories. One is called operative precedence parser. And another one is called LR parsers. LR parsers are classified into 4 broad categories. First one is called LR0, second one is called SLR1, third one is called LLR1, and fourth one is called CLR1. So this is the classification of parsers. Okay. Now bottom-up parsers are also called SR parsers. Now let's go over here. Let's deal with this more. The first thing is brute force parser. Brute force parser cannot use any ambiguous grammar. No ambiguous grammar. Then it cannot use any left recursive grammar. It can use non-deterministic grammar, true, but it cannot use any ambiguous grammar and left recursive grammar. Okay, now let's go over here. Both of these parsers. So this parser, that means top-down parser without backtracking. It cannot use any ambiguous grammar. It cannot use any left recursive grammar. And it cannot use any what? Non-deterministic grammar. Now go over here. All those parsers can use actually left recursive grammar. All these parsers can use left recursive grammar. That means bottom-up parsers. They can use non-deterministic grammar, but they cannot use, this one cannot use any ambiguous grammar. Only this grammar can use ambiguous grammar, but in a limited form, because there is a concept called table. Using the table, we are actually breaking out from ambiguous. Okay, so it should say with operator table. It can use ambiguous grammar. So do you have any question about this? Right?
Yes.
Okay, so we have written here one term, SR parsers. Why those are called SR parsers? What is SR? S means shift. S means shift. R means reduce. Which is nothing but shift means push operation in stack, and reduce means pop operation in stack. So actually these parsers, bottom-up parsers, use some sort of stack data structure. As they are using stack data structure, they use these two operations, push and pop or shift or reduce. That's why they are also called SR parsers. Then this you might say, sir, how about other parsers? Can they use any stack or not? For example, recursive descent parser. This one use the inbuilt stack of the operating system. So we cannot say it uses actually individual stack, but it uses operating system stack. There is an operating system stack, so you know that Windows stack system. So they use that Windows stack systems. Okay, so done. Do you have any question?
Stack key operating system specific?
There is always a stack in the operating system. So whenever you are trying to execute multiple executables, right now if there is no resource for the operating system, definitely your executables are stacked before execution. Right. So this one is executable 1, executable 2, executable 3. So now right now it is operating executable 4. So after finishing that one, then it is going to pop one of the top entries in the stack. Then it will put this one in the operating system. So this way there is a operating system stack there. So Windows recursive parser use the Windows stack. The same way the recursive function use the Windows stack. Is it clear to you? So no difference here actually. Same thing. Done?
Yes, sir.
Okay, so let's move to the next topic. So our next topic is actually how top-down parser and the bottom-up parsers are working. So let's try to give you an grammar. Let's assume I have this grammar. SDREFs A, B, C, D, or A, B derives, I forgot A, so A derives A, or A, B derives B, or B, C derives C, or C. This is my grammar, context-free grammar. Am I right or not?
Yes, sir.
So let's assume I try to. So what is the step? What is the functionality of parsing step or syntax analysis? From a string, we are trying to find out the parse string. Am I right? That
Yes,
is
sir.
the functionality in parsing step. So let's assume I have given this string A, B, C, D. So I'm trying to parse this string using this grammar. So what is the meaning of this? What is the meaning of this? I'm trying to parsing this string using this grammar. What is the meaning of this? I'm trying to generating what?
Parse string.
Trying to generating the parse string. So
Yes, sir.
no matter which parser I'm going to use. Now let's go to top-down parser, TDP. TDP will start from start state. Start from start state. So what is the start state here? S. Starting from start state, it tries to derive this string. So is it possible to derive this string from start state? Is it possible or not? Let's try. S derives A, B, C, D. A derives again A, then this A derives A, this B derives, this B derives B, this C derives. Let's remove one. Yeah, yes. C, then C, finally D. So what's the yield of this parse string? What's the yield of this parse string? A, B, C, D. So this is the yield. Am I right? Is it a correct parse tree?
Yes,
Am
sir.
I right?
Sir.
Okay. Now the question is, sir, somehow you know that actually, yes, it is true. I reverse engineer here. I have taken such a string which can be parsed using this grammar. That is true. Now, how can a parser can actually parse? So the more specifically, how top-down parser can understand that I can actually create parse tree out of this string. That is the question. Am I right? Parser cannot know because I have already taken a string which can be generated. I somehow calculate before. That's why I know this can be generated. But how come a parser can know? Am I right or not?
Yes, sir.
So, can you tell me if I start from start symbol, each step, what I need to do in the top-down parser?
We have to reach the terminals.
We have to reach to terminals, that's fine. So when I start from S, I have two choices, whether I should use this rule or that rule. Am I right?
Yes, sir.
Yes, sir.
So which rule I have used?
Left.
The,
The first one.
the last one, first one.
Yeah.
I have used the first one. So I match AA. Okay, done. Then again, when I get another variable, again I have two options, AA or A. Which one I'm going to use?
First one.
First one. So I again use this one. Then AA match. Fine. Then finally again I get another A. Which rule I'm going to use? The second one. So I got AA match. So then again I got B. B has two options. I have chosen the second one. So BB match. Then again I get C. So I have used the first rule. CC. This is small c. CC match. Then finally this variable C is replaced with small c. This one match. And finally I match DD. So matching is very easy. So what is the $1 million question there? What is the $1 million question? At some point,
Which step to take?
which rule I have to use? Which rule I have to use? So that is the main question in here. Okay. Now let's go to bottom up parser. In bottom up parser, what we are doing actually? What are we doing? We are actually doing the reverse step. We start from the string. So here we start from S. And bottom up parser, PUP, we start from the string. So what is my string? A, B, C, D. So we start from here. Then we are trying to reach to start. So here the movement is start to string. Here the movement is string to start symbol. Somehow I can reach from string to start symbol by using reduce. Then actually I am done. Am I right or not?
Yes, sir.
Though, so here what is happening? Left side is here actually left side of grammar product is replaced with right hand side. And in this case, what I need to do? The reverse one. The right side of grammar should be is replaced with left side. In other words, here we are derive, it is means derive from left side to right side, it is called derive. In this case, we are reduce. Is that clear to you? Is that clear to you?
Yes, sir.
So how can I do that one? So I know that. So initially what I am going to do, I'm going to take this A, this right hand side A, I'm going to reduce it to A. Then what happened? I'll take this A and I make this is A, capital A. So I will take this right hand side, I will make it to left hand side A. Then what? Oh, I'm wrong. I'm sorry. I'm extremely wrong. I'll take at first this A and I'll make it to A. Then I'll take this A and A, I'll make it to A. Okay? Then I'll take this B, right hand side B, I'll reduce it to capital B. Then I'll take this C. At first I will make this C to capital C. Then again I'll take this terminal C and this C to again capital C. Finally I get A, capital A, B, C, D, get the start symbol using this one. Is that process clear to you?
Yes, sir.
So in this case, what is happening actually? What is the $1 million question here? Point to reduce. You see, there are many options to reduce. I have already made a mistake here. Did you see? Because those are not wrong. Those are correct reduction. But the thing is, that is not correct time of reduction. Am I right or not? You can definitely make this terminal A to capital A, because there is a right hand side A, on the left side there is a capital A, but that is not the right time to reduce. So here the $1 million question is, what?
So you always took the last instance.
No, not always it is happening. In this case it is working fine, but trust me, there are some examples you have to reduce the first one. We are going to see when to reduce. That is the $1 million question. Did you get it?
Yes, sir.
Okay, now let's go to derivation. Let's try to derive this. I'm going to derive this. আমি যেখানে একটু বড় করে সি লিখবো, এটা ক্যাপিটাল সি, small c or capital C always confuse. Okay, now if you go to the classification, then you will see it says, if you go to here, this is one of the major top down parser. It says LL1. Isn't it a strange name? Isn't it a strange name? It says LL1. On the other hand, it says LR0. So what is the reason behind writing this way? So let's go back. See. So let's try to derive. In the top-down parser, what is happening? In the top-down parser, what is happening? First, S becomes what? S becomes what?
A, B, C, D.
Small a, capital capital B,
capital C,
capital
small
C and D. So my first step in TDP, if you derive, S derives to then what is my next step? What is my next step? This capital A becomes small a, capital A. Then what is my next step? This capital A becomes small a. Then what is my next step? My capital B becomes small b.
Yeah.
Then what is my next step? My capital C becomes small c, capital C. Then what is my next step? A, B. My capital C becomes small c, D. We are done. What type of derivation is this?
Left derivation.
What type of derivation?
Left
It
derivation.
is leftmost derivation. So remember, it is leftmost derivation.
Okay.
So leftmost terminal, leftmost.
স্যার ক্যাপিটাল সিটা কিভাবে সি হয়ে গেল স্মল সি?
কারণ এখানে একটা প্রোডাক্ট আছে, ক্যাপিটাল সি ক্যান বি অলসো স্মল সি।
স্মল সি, আচ্ছা
এটা স্মল সি। আমারও ক্যাপিটাল সি আর স্মল সি সবসময় কনফিউজড হয়ে যায়, কারণ দুটো একই সাইজ তো। আচ্ছা, সো leftmost variable is replaced first. Here also leftmost variable is replaced first. Then leftmost variable, then leftmost variable, then leftmost variable. Ultimately, we got the yield. So remember that top-down parser is nothing but using LMD, leftmost derivation. Remember, okay? Now let's go to Bottom up parser. What is happening in the bottom up parser? What is happening in the bottom up parser? Can you tell me? What is happening in the bottom up parser? Is it actually LMD?
Start from the string.
It starts from? Is it LMD?
Starts from the string, right?
Starts from string, but there
The
is a,
string থেকে আমি start
yes, I have started from the string, but there is something there. It has also related to some sort of derivation. What type of derivation? Let's do the rightmost derivation.
Rightmost
Let's do the
derivation.
rightmost derivation. Let's do rightmost derivation. S derives, so it is nothing but LMD. No question about that one. So S derives A, B, C, D, capital C. Then if I do the rightmost derivation of this, what I get? A, B, this C would become small c, capital C, D. Am I right? Then this would become A, B, C, D. Then this would become this B, A, B, C, D. Then we'll take this A. Then this would become A, B, C, D. Finally, I will get A, B, C, D. Got the yield. So this is the rightmost. Actually, is it happening here? Actually, is it happening here in the BUP? Is this thing happening here in the BUP? What is happening here? Yes, sir.
এখান থেকে স্ট্রিং থেকে আমরা ব্যাকট্র্যাক করি
আমরা প্রথম কোনটাকে ইয়া করেছি প্রথম which one I have reduced? Can you tell me?
থার্ড এটা
First, third A becomes A. So let's go over here. Let's go over here. এখান থেকে যদি এখানে যান এখানে কি হচ্ছে থার্ড এটা
হ্যাঁ
A হয়ে যাচ্ছে this A
হ্যাঁ।
becomes capital A. Am I right?
ইয়েস
Then what I did here, second A and third capital, second A and the next capital A becomes capital A. Am I right?
ইয়েস
So in this case, see, this two becomes this in this step. Am I right or not?
হ্যাঁ স্যার
Now, next step, what we did actually? What we did?
ক্যাপিটাল A capital
Small b becomes B. So,
Yes.
small b in this case, small b becomes B. This one. In this case, then next step, second C becomes capital C. This one becomes C. So this one, and finally this two C becomes small c, and the next capital C becomes this, and finally I get this. So what is happening here? This thing is LMD. This thing is RMD. But what is happening here? Reverse of
RMD
RMD. So remember, it is nothing but reverse of RMD. All right. So in bottom up parser, reverse of RMD is going on. Okay. Done.
সব বটম আপ পার্সারে
সব বটম আপ পার্সারি রিভার্স অফ আরএমডি হয়, সব টপ ডাউন পার্সারি মেজরলি LMD হয়, LMD হয়. Okay, so let's start officially one of the parser. The first parser we are going to study is nothing but LL1 parser. So LL1 parser.
টপ ডাউনে কি এলএমডি আর এমডি দুটাই করা যায়?
RMD কি বলেছি একবারও? আমি তো বলেছি রিভার্স অফ RMD.
ও
Acha. So why such a strange name? The first L. What is the meaning of this?
left
So whenever we get a string, we are searching from which side? When I have given this A, B, C, D, when you try to derive this one, you are searching from which side? From the right side or left side?
left side
So scanning is happening from left side. Am I right? We are reading from the left side.
Yes, sir.
So this
Yes.
L is nothing but left side scanning. Second L, what is this second L? Come on. It is nothing but LMD because it's a top-down person. And what is this one? One means how many symbols are take care or look ahead. That means before taking any decision, how many symbols we are taking care of. We are taking care of one symbol. That's why look ahead is one. Okay? We are
Okay,
going
sir.
to dealing much more. Before that one, let's draw a very schematic diagram of LL1 parser. The schematic diagram of LL1 parser is something like this. It should have an input buffer. Why I need an input buffer? How do I get input buffer? Input buffer. What is input buffer? Tell me.
The stack.
What it stores? It is not stack. Buffer is not stack. Buffer is a queue. Buffer is a queue. Buffer is a queue. Buffer is not stack. So how do we get the input of the buffer? Tell me. From previous step. So what is the previous steps of the parser? What is the previous step of parser? Come on.
Scanner.
Scanner or tokenizer. So all the tokens should be stored over here. And remember, at the end of the token, there should have a special symbol. We call it dollar or any kind of thing if you want. What is this dollar means? What this dollar means? End of
End of the
token.
yeah.
End of token. All right. Then we have here we have LL1 parser, the main part, the algorithm, the parser, the black box, which is going to do the parsing. So this one is my main part. And just below this, there will be a helping hand, which would be called LL1 parsing table. Okay. So LL1 parser, the black box, the main part, taking help from input-output buffer, and it is also taking help from LL1 parsing table. And there will be another helping hand because this is a push-down automata that is nothing but a stack. Okay, so it is also taking help from a stack. So this is the schematic diagram of LL1 parser. Okay, and remember another thing, at the bottom of the stack, there will be also a dollar. What this dollar means? What this dollar means? End of
End
stack.
of the
So when we can understand that parsing is complete, whenever I reach input output buffer to dollar and also stack to dollar, that means when I get dollar and dollar,
the
parsing is successful. So these dollars are nothing but actually meaning in end of the stack and the end of the buffer, and also they are like a sentinel guarding character. Is it clear to you guys? Done?
answer.
Okay, so let's continue with LL1 parser. Before starting LL1 parser, we need to study two concepts. So what is our main aim? Our main aim is actually developing LL1 parsing table and actually then write an algorithm for LL1 parser so that we can parse. So at first we have to construct LL1 parsing table for a grammar. So constructing LL1 parsing table, we need two important concepts. One is called first. Another one is called follow. One is called first, another one is called follow. Now what is first? Let's assume something like this. What is my grammar in the previous example?
A.
What is my grammar?
Oh, sorry,
This is
grammar.
my grammar.
A
This is
capital.
my grammar.
S derives
A capital
S derives.
sorry,
S derives.
small letter A, B,
Right.
C.
Small a, capital A, capital B,
Capital B.
capital C, small d.
Small d.
So whenever we go from left side to right hand side, we derive something. That means we derive. The first symbol, the first terminal we encounter at RHS is called first. Did you get it? Did you get it or not? Whenever we derive, that means from left side to right hand side, the first terminal we encounter at RHS is called first. Is it clear to you?
Sir,
Is it clear to you?
Side.
So left hand side is S. If we derive to right hand side, so what would be the case? A, capital B, capital C, small d. So what is the first terminal we are encountering here? A. So first of S is A. Is it clear to you guys?
Yes.
Then S can also derive to A. In this case also, we are encountering the first terminal is A. So again A. So we don't need to write it again. Is it clear to you?
ফার্স্ট কি একটা ফাংশন?
It is not function. First, it means actually first of S, first of variable S. It is nothing like function. But whenever we are trying to write an algorithm for finding first, definitely it would be a method. Am I right? That's why I write this concept. Okay. Clear or not? Tell me.
Sir, বুঝছি এবার।
Acha, এখন let's assume something like this. Let's take another grammar. S derives A, B, C or AA. B derives B or epsilon. And C derives C or epsilon. Now what would be the first of S? S can derive AA. Am I right? So first of S is of course A.
Yeah.
A. Also, S can derive epsilon. Am I right?
Yes, sir.
The first of S is also epsilon. Right?
Yes, sir.
Now let's come. This product is done. This product is done. How about this product? First of
B.
S is nothing but. First of S is nothing but.
B, A.
A product लिखी नहीं. So A is something like this. A or epsilon. So what is first of S?
A, sir.
What about the first of variable A? It is a variable. It can be terminal now. So first and follow should be always terminal, not variable. So how can you find out the first of S in this case?
এর ফার্স্ট বের করব তারপরে
First of A. What about the first of S? First of variable A, because S can derive A, B, C, then A can derive something.
Yes,
So actually, if this is the process, then whatever in this case is the first, that is also first of S. Am I right?
yes, sir.
Yes.
So in this case, what would be first of ABC? First of ABC is nothing but
Small a.
first of capital A. What is first of capital A?
Small A.
Small a.
Small a. So
Small A.
small a. Okay, fine. So small is done. First of A can be also
Epsilon.
first of A can be also epsilon. First of A can be also epsilon. Up to now we have got A and epsilon. So how can you do that? So if you now put this epsilon, then what happened? This A would be vanished. Am I right?
G, sir.
Yes.
Which one is going to be exposed?
Sir, abar.
If you put epsilon over here, then this A is vanished.
B.
And what would be exposed? B. So in this case, what happened? S derives ABC, then this A is getting epsilon. So it is vanished from counting.
Yes, sir.
So we
then
get
capital
B.
B.
So then again, what would be the first of S? Whatever B can be derived. Am I right?
Yes, sir.
Because this
Yes,
one
sir.
getting first then, right?
Yes, sir. Yes,
So
sir.
what would be first of B? First of B is nothing
Small
but
b.
Small
first
b
of
or
B is
epsilon.
nothing but small b or epsilon.
Or epsilon,
So
right.
we have to put here B as well. Am I right?
Yes, sir.
Now again B can be epsilon. So B can be also vanished. If B is
then
vanished, then what happens?
C. We
C.
get capital C.
Capital C. So what is first of C?
Either small c or
Small c or epsilon. Then actually C should be also there. Am I right? Then if you put
Yes, sir.
epsilon, then what happened? This one is also vanished.
Yes,
Am
sir.
I
Then
right?
we get
We get a big epsilon.
yes, sir.
We get a big epsilon, already epsilon is there. So we have done. So these are the all rules I have defined with you. Now, how can we actually write the algorithm for first? These are the all rules there. Cyclically, you have to do this stuff. So what would be the algorithm for finding first?
So first
We're going to write systematically all those. So number one, first of LHS is equal to first of RHS. Am I right? So
yes, sir.
A, if RHS equal to epsilon, then RHS equal to epsilon, then
move to the next.
না ফার্স্ট অফ এলএচএস যদি পুরো আরএইচএস টাই যদি এপসিলন হয় তাহলে ফার্স্ট অফ এলএচএস ইকুয়াল টু এপসিলন নাম্বার বি if RHS starts with terminal
then first of
LHS is
terminal.
this terminal.
Yes.
Now let's go to second row. If first variable in RHS first variable RHS has first equal to epsilon, then what? If first variable in RHS is first equal to epsilon, then
B equals terminal.
first of LHS is
HS is terminal.
first of
Epsilon.
first of next variable
right.
of RHS. Am I right or not?
Yes, sir, you're right.
স্যার এখানে এলএইচএস এন্ড আরএইচএস কি পার্টিকুলার সিম্বল গুলোকে বোঝাচ্ছে?
হ্যাঁ, এটা হচ্ছে কি আমার রাইট হ্যান্ড সাইডের যেটা ভেরিয়েবল LHS is my variable. In context-free grammar, left-hand side is always variable. Right-hand side can be combination of variable and terminal. Am I right or not? According to Chomsky normal form, that is the definition of context-free grammar.
জি স্যার। রুল নাম্বার 1 কি বলছে এখানে কি ইফ হবে কোনো?
No, এটা একটা general statement দিলাম। এটা always true actually. First of LHS is equal to first of RHS. You can write this way. This is one. That would be fine. Okay. That is a general rule. First of LHS is always first of RHS. Okay. Now, if first variable in RHS is first equal to epsilon, then first of LHS is nothing but first of next variable RHS. A. And continue this way. Am I right?
Yes, sir.
If then the next one would become the epsilon, then we'll go to next. This way it will continue. Am I right?
So it will be a recursive term.
It is a recursive term. Yes, recursively we are trying to compute. Fantastic. Then it is a wonderful thing. And big epsilon creates, that means That means we can say if all terms in RHS become epsilon, then first of LHS is epsilon. So we are done with the algorithm. But he has already pointed out the concept. That means this one is actually recursively generated. These two are fixed. We are going to do one, right? If the right hand side is epsilon, then first of LHS is epsilon 1. Then this one, first, if RHS starts with the terminal, first of LHS is terminal. We do it 1. But this one is recursive. Recursively we are doing. And again it is going to generating more and more fast. And then actually it is going to change other fast as well. Am I right?
Yes, sir.
So let's take an example. Then it will get into. So remember this algorithm. This is important.
লাস্টের রুলটা কি বলছে?
If all terms in RHS become epsilon, then first of LHS is epsilon, big epsilon. So let's take this example. SD drives A, B, C, D, E, or D or AA. A derives AA or epsilon. B derives BB or epsilon. C derives, capital C derives small c. D derives DD or epsilon. Done. So how can you find fast and final? How can you find fast and final?
So we will start with first of S.
Don't start with S. There is a very folklore law. Do you know what is folklore law? Do you have any idea about folklore law? What is folklore law?
So don't know.
Folklore law means mane gatha. It means old saying. You know what is old saying? What is old saying?
Like it has been said by previous generations. Like
Previous generation, you cannot. So those are actually valuable because those are comes from experience. Am I right or not?
Yes, sir.
So there is an old school thought, old saying, or folklore tale that rule is called Occam's razor. Do you know Occam's razor?
No, sir.
Occam's razor means whenever you're trying to solve a problem, always try to solve the simplest one first before going to complicated one.
Okay, sir.
Then what happened? It is very wise saying, because if you use the simple one, then you are done with using only rule number 1. Am I right?
Yes, sir.
Then you can go to rule number 2. As maximum laws are already done with rule number 1, you would have few recursion. Am I right or not?
Yes, sir.
If you try to use this rule first, the complicated one first, then what happens? You are again and again inside the recursion, everything getting hodgepodge. So it is better to use the wise saying first, the Occam's rule, that's trying to solve the simplest one first, using rule number 1. Is it clear to you?
Okay, sir.
So using only rule number 1, which one I can solve here? Which one I can find first?
C.
So you see, this one has recursive term, so it should go to rule number 2.
Yes, sir.
So how about this one? This one does not have any recursive term on the left hand side. There is a terminal, so we can use only rule number 1. So first of A is what? A comma epsilon. First of B, there is no recursion on the left hand side, only terminal. So we can use only rule number 1. B or epsilon. C is also simple. D is also simple. D or epsilon. We are done. Now let's go to rule number S, and we know that they are not going to change anymore. So there is only one rule remaining. For that one, we have to use the recursive rule.
Yes, sir.
Then it is getting very simple. If there are two recursion, then they are going to mutually affect each other. But right now, there is no chance, right? So this is the Occam's rule. Try to solve the simple one first. And in this algorithm, which one is simple? The rule number 1. So we're done with rule number 1. Now let's go to rule number 2. So rule number 2, this second part is also very easy. What would be the first of this? A. Am I right?
Yes, sir.
Now let's go to second one. First of S is nothing but first of RHS. And this one is terminal. So first of this terminal. What is the first of this terminal? A
Yeah,
and
we already
epsilon.
figured it out.
It is already there, so no need. If you put epsilon, this one is cross out. So B is exposed. So we have to go first of next variable RHS and continue. So what is first of B? First of B is nothing but B or epsilon. So write B. If you put epsilon, this one is cross out. So C, capital C is popped out. Now what is first of C? Small c. So C, and we are done. Did you get it?
Yes, sir.
So this is how we are finding the first.
আচ্ছা আচ্ছা স্যার তো যেহেতু আমরা টার্মিনাল হিট করি নাই এপসাইলন হিট করি নাই we didn't move on to the next variable.
No, C taken a stop হয়ে গেল because we got the terminal. Whenever we got the terminal, that means rule number 1B.
Yes, sir.
We got the terminal, we are stopped. We cannot
Yes.
move further.
না সো ওইটাই ক্রস চেক করে নিলাম আর কি
Yes. Let's try to solve another problem, then we will stop here. Next class, we'll start follow and then start drawing the parsing table. Okay, and parsing.
ওকে স্যার
So let's take another grammar. SD refs A, B, C, D, E or A. A derives A. Okay, so this is my grammar. What would be the first of this? Again, was saying Occam's razor. So which one I'm going to use first? Rule number 1. Which product can be derived only using rule number 1?
A, B.
This one is complicated because there is a recursive term on the left side. So forget about this. This one is simple. So A epsilon. This one is also simple. B epsilon. This one has recursive term. So pending that one. This one also is recursive term. This one is epsilon. So this one is also epsilon. So done. Now let's take another one. Again apply Occam razor. Again apply Occam razor. So this rule is very complicated. So let's take which one? This one. What is first of C? There is epsilon there. So epsilon. And first of B. What is first of B? First of B is nothing but
Small b.
small b and epsilon. If you put epsilon here, this is cross out. B is exposed. B is already written, so don't need. Now let's go to here. First of D is nothing but epsilon is there, so epsilon. Then first of A. Am I right? What is first of A? A.
Small a.
And epsilon. If you put epsilon, this is cross out. D is exposed. Now using rule number 1B, we get also D. Am I right?
Right, sir.
Now let's go to final one, S. This one is simple using rule number 1. A. How about this one? First of S is nothing but first of A. First of A is nothing but A and epsilon. So A is already there. If I put epsilon, this one is cross out. Now B is exposed. So first of B is nothing but B or epsilon. So if we write B, if we put epsilon, this one is cross out.
C is exposed now.
First of C is nothing but B or epsilon. B is already written. If I put epsilon, this one is cross out. D is exposed. First of D is nothing but A is already written. D is not written, so write D. If you put epsilon, this one is cross out. So
Then we reach
E
epsilon.
is exposed. First of E is nothing but epsilon. So this one is also cross out. This makes the big epsilon. So that is epsilon. Did you get it?
Yes, sir.
Yes, sir.
So today, in the weekend, I'm going to post some homeworks of first. You'll try to solve those first. All right, guys. Should you stop here today?
Yes, sir.
Sure.
Sir,
Is there any more questions you can ask me? Any question? Attendance, right? Attendance.
জি স্যার
Attendance is immaterial. If you don't participate class, you would definitely get very bad grade.
স্যার
So-
আমরা যদি ফার্স্ট অ্যালগরিদমটা কোড করি তাহলে আমরা ওই যে কোন প্রোডাক্টটা কমপ্লেক্সিটি কোনটার বেশি আর কি মানে কম্পেয়ার
যেটা
করে
যেগুলো রাইট সাইডে রিকার্সিভ টার্ম আছে সেগুলো কমপ্লিকেটেড, that would fall on the rule number 2 because rule number 2 itself is a recursive. Am I right? So simple calculation.
আচ্ছা
Simple, right?
Yes, sir.
If right hand sides have some variables at the beginning, there are some variables that is definitely recursive. That is definitely recursive. So that is going to
Yes,
use
yes.
the recursive term, right? Any more question?
No, sir.
no, sir.
না স্যার প্র্যাকটিস করে তারপর
Practice. You need practice. Practice makes a man perfect. Old saying again. Old saying is always good. Old people are good. All right, guys. See you then in the Saturday. Saturday, you would not see me until and unless you will call me because I'm going to post the time. Then you are starting the exam actually, the demo quiz. So there is no need of communication. The time
Okay.
you will start the quiz, you will end. And the system is very easy, so you will understand. Okay. See you then. Have a nice weekend. Take care. Bye.
টেক কেয়ার স্যার থ্যাংক ইউ বাই